everyone. Today we are going to study Biot Savart Law. Let us start. Biot Savart Law states that the magnetic intensity at any point due to a steady current in an infinitely long straight conductor is directly proportional to the current and inversely proportional to the distance from point to conductor. So let us prove this statement by considering a long conductor, and through this conductor current I is flowing. Let us consider a point P where the magnetic field due to the conductor is to be studied. Okay, now let us consider magnetic field B or magnetic induction due to the small element, that is this dl. Okay, at a point P and having a position vector r from the given element, or we can say this is the distance r, vector distance r, which is making an angle theta, or this is the angle between dl and r. Okay, this is the dl and this is r. So this is the angle between dl and r is theta. Then according to the statement, dB is directly proportional to I, current. dB is directly proportional to dl, that is the small distance we have considered, and this dB is inversely proportional to r square. Okay, and this magnetic field is found to be least when the angle between the r and dl is smallest, that is 0, and it is largest when the angle is 90 degree. So dB is directly proportional to sin theta, that is known. So by using all these equations, what we have done, we have combined all the equations, and this becomes dB is directly proportional to I, that is current, dl, that is the small distance, sin theta upon r square. And when we remove this proportionality sign, a constant is introduced denoted by k. So the equation becomes dB is equal to k I dl sin theta upon r square. And the value of k is mu 0 upon 4 pi, which is nothing but 10 to the power minus 7, and its unit is Henry per meter. So when we substitute these value in this equation, that is the value of k in this equation, the equation becomes dB is equal to mu 0 upon 4 pi into I dl sin theta upon r square. The magnetic field due to any structures for which all the dB along the length of this structure has to be added to find out the total B, isn't it? This dB is considered to be a small field. for small distance, that is dl. Now when we are going to find out the total B, it can be integrated. Now let us see the application of Biot Savart Law. This Biot Savart Law is used to calculate the magnetic responses even at the atomic or molecular level. It is also used in aerodynamic theory to calculate the velocity induced by vortex lines. Let us see the importance of this law. This law is similar to Coulomb's law in electrostatic. The law is applicable for very small conductors to which carry current, and this law is applicable for symmetrical current distribution. Thank you.